All right, so let's go over some of the 5.1 practice questions. So lay it on me. Blake, you want to start us?
Okay, for number 18.
Number 18.
Did you have to like simplify like each thing in the parentheses, like for 3a to the -1, b to -2? Did you have to do that like before?
So how I would approach this is you could move the a to the -1 and the b to the -2 to the denominator and then simplify, or you can do it at the end. So what I would do is I would go ahead and just multiply everything through and then move things where they need to go.
So it didn't matter what order you did it?
Okay. So I would start with -5 times 3 is -15. A squared times a to the -1, I would take 2 plus -1 is 1. So that's just a. And then b cubed plus b times b to the -2. So 3 plus -2 is just b. Okay? Yes, sir.
On the question like 19, what do you do when there's a negative exponent on top and on bottom?
Okay, so on 19, what I would do is I would go ahead and rearrange these so that my exponents start off positive. So that means that I'm going to move this piece to the denominator, and I'm going to move this piece to the numerator.
Okay.
Because they both have negative exponents. So this would be 3a to the +1, which is just 3a, and then 3a to the 4th. M to the 5th stays on top, and m squared stays on the bottom. So then when we simplify this, this becomes 3a m to the 5th over 3 to the 4th is 81. A to the 4th m squared. 3 over 81 reduces to 27 in the denominator. A cubed in the denominator, and then m cubed on top. The other interesting part about this problem is that notice that our bases are the same here with 3a and 3a. So you could also deal with this as you could reduce the 3a itself first and have it become 3a cubed in the denominator and then go that way. That would work too. Sure.
Say like the work that's in purple for 19. Say m squared was m to the -2 exponent. So when you put that on top, what does that become on top?
So you're saying if you had m to the 5th over m to the -2.
Yes.
So then I would move my m to the -2 up to the top. So this would become m to the 5th times m to the +2, which would just become m to the 7th. Because 5 plus 2 is 7.
Oh, okay, so it's plus.
Mm-hmm. What other questions? Hannah?
Number 20.
20. All right, 20 is fun. I promise. It's fun. Okay, so the first thing I would notice is that I am taking a fraction and dividing it by another fraction, right? So if I had 5/3 over 7/6, I could rewrite that as 5/3 divided by 7/6, and then how do I divide fractions? Flip which one? Yeah, so keep the first one, change it to a multiply, and flip the second one. Okay? So that's what we're going to do here, because we are dividing this fraction by this fraction. So I'm going to keep the first fraction, 3l cubed k squared over j cubed. I'm going to change the division to a multiplication, and then I'm going to flip the denominator. So it's going to be L to the -2 over 9k cubed j. Okay. Everyone okay with that step?
Yeah. Wait, why would it still be -2 on the L because you flipped it?
But I'm not flipping it using like exponent rules or stuff like that. I'm just using the rule of dividing fractions. So I've really just taken the reciprocal. I haven't moved the L to a different spot. Does that difference make sense? Okay. So next, the idea is you can go ahead and move the L down if you don't want to deal with it, or you can wait and deal with the negative exponent later, which to me, I'm more likely to go ahead and multiply across the top and multiply across the bottom. So if I multiply across the top, I'm going to get 3 L cubed times L to the -2. Just L. And then K squared over 9K cubed J to the 4th. And then we can reduce that. What would be left on top? Just the L. Because 3 over 9 turns into 1/3, so 3 on the bottom. K squared over K cubed turns into a K on the bottom. And then J to the 4th. I just simplified.
How'd you get that then?
How'd I get this?
Yeah.
So 3, I just multiplied across the top and across the bottom.
Oh, okay.
Okay? Morgan, did you have one?
Yes.
Okay. Number 5. All right, Morgan, how did you start this? It's okay if you didn't know. I'm just asking if you did take a path.
No, I did.
Okay, tell me how you did.
I'm not exactly sure that's what I did. I squared everything. So
Okay.
-3 squared, and then I did A squared and B squared.
Okay, so you took each term and you squared it.
Yes.
Okay? -3 squared is 9. Okay, a to the 5/2 squared. What are we going to do with those exponents? We're going to multiply them. So 5/2 times 2 is just 5.
Oh, okay.
Because it's like 2 over 1.
I did 5 squared.
Yeah, so we got to remember our rule when it's like x to the 5th cubed, we end up multiplying those powers. It would give us x to the 15th. And then we'd have b to the -8. So we would have to move the 8 to the bottom. So 9a to the 5th over b to the 8th. Matthew?
Number 4.
Okay. Oh, sorry. There's the rest of that if you still needed it. All right, number 4. Is 2 to the 3/2 over 3 to the 1/2. So the -2 power. Matt, what did you do first?
I turned them both into improper fractions.
Okay, this is not a mixed number. This is 2 to the 3/2 power. So we can't do that. Okay? The first thing I would recommend trying here is we've got a negative exponent. So I'm going to flip the inside.
Oh.
So this is going to become 3 to the 1/2 over 2 to the 3/2 raised to what power? +2. All right, so then we have power to a power. So we're going to keep the base the same and multiply our exponents. So this becomes 3 to the 1/2 times 2 power over 2 to the 3/2 times 2 power. What can I put the 2 over to help me? 1. So this becomes 3 to what power if I have 1/2 times 2 over 1? 3 to the 1st, which is just 3. And then 3/2 times 2 over 1? 6 over 2, which is just 3. So that gives me 3 over 8. Sean?
What exactly would 2 to the 3 over 2 power actually be?
I mean, it's not a number that I could specifically evaluate for you necessarily. Tomorrow in class, we're going to talk about what a fraction as an exponent really means. So we'll go into how that applies to all of these rules. Okay? Any other questions you'd like me to work?
Can I ask, like, not a homework question, just a question?
Is it about exponents? Yeah, sure.
So if it was, like, a to the 0 power, but then, like, in parentheses it was, like, squared, no matter what, it'd still be 1.
Yeah, because think about it. You could either go ahead and raise a to the 0, which is 1, and 1 squared is 1. Or you could do a to the 0 times 2, which is a to the 0, which is still 1. Okay? Yeah, Jason?
Can you do the second one?
Yeah, the, like, random floating one there.
Oh, I didn't see that.
Yeah. I got it almost right. I was actually pretty close.
I'm going to call this 11.5. It's kind of like floating in the middle of 11. Okay, so Jason, how'd you get started on this?
Okay, well, I wasn't really sure what to do, so I kind of like wrote them out next to each other. I wasn't.
Okay, so you weren't sure.
I mean, I know like somehow you have to put the top part on the bottom.
Good. So we see that negative exponent in the numerator, so we've got to move that whole base into the bottom. So it's exactly what I would do first. I would rewrite this as 1 over, because if I move this whole thing to the bottom, I'm left with nothing in the numerator. So it's got to be 1 over 2a cubed b squared c to the positive third power now. And then 3a squared b cubed c squared.
So I wasn't sure if I wasn't sure like how you like combine it.
Yeah, so these end up being multiplied. So I would go ahead and simplify each piece. So this would be 1 over 2 cubed is 8. Then it would be a to the 9th, b to the 6th, c cubed. And then if I start to simplify this piece, 3 squared is 9, a to the 4th, b to the 6th, c squared. And all of these are being multiplied. So you're going to go ahead and multiply the ones together that you can. So 8 times 9 is 72. A to the 9th times a to the 4th, a to the 13th. B to the 6th times b to the 6th is b to the 12th. And then c cubed times c squared, c to the 5th. All right, we have time for maybe one more if you've got it. Yes, ma'am.
Can you do 15? I think I'm just getting confused on how you multiply the exponent fractions together.
Okay, so let's look at 15.
I hate fractions.
All right, Megan, can you tell me how you tried to start this off?
The first thing I did was I switched them since they were negative.
Okay, great. So you saw negative exponents inside. So that means we move this to the numerator and this to the denominator. So I totally agree with that. That would give me 3 to the 23rd ninths over 3 to the 5 ninths. To the 3 halves. Okay? What I'm going to do from here is go ahead and simplify the inside of that parentheses. Because we've got 3 to a power over 3 to a power. So I can subtract those exponents and simplify the inside. And it's going to keep your numbers a lot more manageable than multiplying the fractions first, then subtracting. So I've got 23 ninths minus 5 ninths. What does that give me? 18 ninths to the 3 halves, which is 3 squared to the 3 halves power. What do I do with the 2 and the 3 halves then? You multiply them. So 6 over 2 would be 3 to the 3rd, which is 27. Alrighty?
Why is it 3 to the third?
Because 2 times 3 halves is 2 over 1 times 3 over 2. So 6 over 2 gives me 3. Quick one, because then we got to start notes. Okay, go ahead.
Wait, so if you flip both of them, then they both become positive. So if there was a negative on bottom and then a negative on top, it would switch it.
Yeah, the idea is that I can take, by taking this piece in the denominator and moving it to the numerator, I've made my exponent positive. Same idea, by taking my numerator and moving it to the denominator, I've made that positive. So it's not that they were both positive, it's that you just did each piece separately and it ended up switching them.
Okay, but if so say there was like a positive on bottom and a negative on top, and you switched it, would it turn that into a negative?
So you're saying, what if it was like...
Like for the star one, what I did, which I got wrong, is I switched it, both of them, for some reason, instead of putting them together, because I didn't know you could do that.
Oh, okay. You're talking about back on this one?
Yes.
Yeah, so on this one, only the numerator has a negative exponent. So the denominator stayed where it was, and just the numerator came down.
Right.
Does that make sense?
Yes. So you shouldn't switch.
Correct. You only can move it, you only want to move it if if the exponent is negative. If the exponent of whatever base is there is positive, you want to leave it where it is. Whether that's the numerator or the denominator. All right, I'm going to pass you out your notes real quick.
Are we gonna go over why number or anything to the
We'll talk about that in a minute.
Yeah, I just thought about
All of this is
Oh my God.
Okay, ladies and gentlemen, I need you to quiet down. Guys, I need you to quiet down. All right, let's go ahead and get started on these notes. I would like for you to go ahead and work numbers 1 and 2, please. 1 and 2. Okay. What is answer number 1? 1. Yay. Huh? Okay. You don't understand why it's 1?
No, I understand.
Oh, okay.
I just don't know what this is.
Okay. Let's look at number 2. What are we going to use for number 2? Good. Base times height over 2. So, base times height over 2. Okay. Guys, I need the side conversations to stop. All right. Let's go ahead and simplify the numerator. So this would be 2 a cubed times a cubed is a to the 6th, a to the 6th, b to the 7th over 2. Your 2's cancel. You should have gotten a to the 6th, b to the 7th.
Wait, so you can't do
A to the 9th.
I'm sorry?
She was saying
No, you did not going to do Pythagorean theorem here. Okay, let's look at 3. What type of figure is this? Cylinder. What's the formula for volume of a cylinder? Okay, and what's the area of a base of a cylinder?
R squared.
So pi r squared h. So this is my radius, and this is my height. So my volume is pi times 5x to the 8th y cubed squared, thank you, times 3x to the negative 2 y to the 0.
Could you go ahead and just say 3x negative?
Okay? Okay, so let's go ahead and simplify this. If I square, I'm only squaring 5x to the 8th y cubed. So 5 squared is 25. X to the 16th, y to the 6th, times the y to the 0, as many of you already noticed, can cancel out, just becomes 1. The 3 would stay up here, but I'm going to go ahead and move x to the negative 2 down to the new denominator, so it becomes x to the positive 2. Okay with that? All right, then just simplify. So I've got 3 times 25 is 75. X to the 16th over x squared. Good. X to the 14th. Y to the 6th. Pi.
Would you have to, like, would you necessarily have to write the x squared under?
No.
Okay. What? Like, I didn't know if there was like a certain way, you know, like.
Nope. As long as you get there, you're good. Other questions on this problem?
Wait, yeah.
Okay.
You always try to find that.
Oh, duh, you can't look. Okay.
All right. We're going to skip number 4.
Do you always write pi last, or do you put like 75 pi?
That's fine. All right. Now let's look at number 5. Guys. Thank you. Write an expression for the radius of a circle if the area of the circle is 4 pi x to the 8th y squared. So what formula are we going to need to use? Okay, so area equals pi r squared. All right, well, we know that the area is 4 pi x to the 8th y squared, and that's equal to pi r squared. What are we trying to solve for? R. So what could we do? Okay, if we divide both sides by pi, our pi's are going to cancel. So I have 4x to the 8th y squared is equal to r squared. Yeah, so I would square root both sides. And there's no addition or subtraction in here, so you are allowed to take the square root of each individual piece. So the square root of 4 is 2. The square root of x to the 8th? Good, x to the 4th. And the square root of y squared is?
So exponents you divide by 2.
Would this be plus or minus?
You can't have negative for
Is that a yes? You just divide by 2?
Huh?
Did you say yes? The exponents just divide by 2?
Well, you think about it if you want to know, if you want to take the square root of x to the 8th.
Oh, 4 times.
That's the square root of x times 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 x. So there's 4 pairs, right?
Yeah.
So there's 4 on the outside, so it becomes x to the 4th. Okay? Okay, 6 is one you know how to do, so we're going to go ahead and skip it.
Like, would we, like, not in this case because it's like a real world situation, but do we need plus or minus?
If you're putting in the square root, yeah, and it's not a radius or a height or something, yes, you would put plus or minus. Okay, let's go ahead and flip to the back. Okay, so here what the situation is that we've got x in the exponent, and we are trying to solve for x. So our goal is going to be to get the same base on either side of the equal sign. Okay, so how could I simplify the left-hand side here?
Subtract 2 to the 7.
Nope. How do I combine 2 to the x times 2 to the 7?
It's 2 times, or 2 to the 7x.
X plus 7. So 2 to the x plus 7 is equal to 2 to the 5th. So now, if 2 to the x plus 7 is equal to 2 to the 5th, then what must be true about your exponents?
It has to be -2.
Well, your exponents have to be the same. X plus 7 has to equal 5. So x has to equal -2. So your goal here is to get to this step, to get the same bases raised to powers equal to each other. So that then you can set the powers equal. Okay? All right, let's look at 8. How could I simplify this left-hand side?
So 12 to the power of 5x.
Good. So 12 to the 5x power equals 12 to the 100th power. So what do we do now? So we set up our little equation. 5x would have to equal 100. So x has to equal 20. Questions on that? Do you have a question? Oh, no. Okay. All right, let's look at number 9. What do you think we could do first on number 9?
Get rid of the y6.
Yeah, the y to the 6's can cancel. So I have 5 to the negative 2x equals 5 to the 5th. So what can I do here? Good. My exponents must be equal, so negative 2x equals 5. So x equals negative 5/2. You okay on that one? Okay. Okay. Now on number 10, we don't already have the same bases on each side. So we're going to have to do a little bit of rewriting in order to get ourselves the same bases on each side. Okay? So we've got 2 to the 2x plus 1 is equal to 32. Is there a way to rewrite 32 as a power of 2? 2 to what power is 32? The 5th.
Like, how could you, if it was a larger number, how would you be able to tell?
So I wouldn't give you one I wouldn't expect you to know. But I do expect you to know up to like 2 to the 5th, 2 to the 6th. You should be able to recognize those. You should also be able to recognize up to 3 to the 4th, which is 81. Okay? So I would spend some time making sure you're comfortable with the powers of 2, powers of 3, because those will come up a lot. Otherwise, there'll be squares and cubes that you've memorized already. Okay? So remember when we memorized the squares and cubes? If you've forgotten them, those are still expected to be known. So make sure you start reviewing them early enough so that you're feeling good for them for the test. Okay, so I have 2 to the 5th. Now on the left, I still have 2 to the 2x plus 1. So now this just looks like our other problems, right? So we can set 2x plus 1 equal to 5. 2x equals 4. So x equals 2. I would definitely double check your work. So plug 2 back in. If I plug 2 back in up here, I would have 2 to what power? 2 to the 5th. And does that equal 32? Yeah. Alrighty, let's look at number 11. How could we rewrite 27 with a base of 3? 3 cubed. 3 cubed is 27, right? Well, 27 was being raised to the x minus 1 power. So now 3 cubed is being raised to the x minus 1 power because you just replaced 27 with 3 cubed. Okay? In order to simplify this, it's really important that you remember you're going to multiply 3 by this whole exponent. So you might want to throw in parentheses, perhaps. So this would be 3 to the 4th equal to 3 to the 3x minus 3 power.
So you just multiply it as if it was just like regular numbers and not.
Yeah, because our rule for a power to a power is that we multiply those powers. So we're taking 3 times x minus 1. Okay? And then we can set up our little equation. 4 equals 3x minus 3. 7 equals 3x. So 7/3 is x.
And then how to have this like the bases have to be the same.
Uh-huh. This only works because we got the bases to be exactly the same.
Wait, is it no solution if like you know that the basis cannot match?
Not necessarily.
So like it was like 28 and like 3.
Not necessarily. All right. Let's look at number 12. Ideas on how we could approach number 12. Lindsay?
Well, they both have 4. So we could go
Wait. What do you mean they both have 4? Try and use good language.
16 can go to the power of 2. Well, 4 can go to the power of 2 equals 16.
Okay.
And 4 to the power of 3 equals 16.
Great. So we can rewrite both of these with a base of 4. Very good. So 16 rewritten with a base of 4 is 4 squared. And that whole thing is being raised to x plus 2. And that's equal to, how can I rewrite 64? 4 cubed. Questions on that step? Okay. So this is 4 to the 2x plus 4 equals 4 cubed. So I've got that 2x plus 4 equals 3. 2x equals negative 1. X equals negative 1/2.
You can also do it 2 to the square.
Yeah, you could have used a base of 2 here. 2 to the 4th and 2 to the 6th. Yeah, you'd be fine. But if there's a bigger number, I'm going to go with that because then my exponents are going to be smaller. Okay? Question?
If you had one where the bases were the same, but one had a negative exponent, would you just leave it?
I don't understand what you're saying.
Like if you had the bases were the same, but then one had a negative exponent, would you still leave it because the bases should be the same and just multiply it out? Okay.
Okay. Now let's look at 13. Take a second and look at this problem and see if we can rewrite these with the same base. I don't want you to call it out. I want you to take a sec and look and try on your own. what base might we try and use? 5. I would agree. I can rewrite 1/25th as a power of 5. What would my exponent have to be in order to turn this into a fraction? Negative. So I know my exponent's going to be negative. That would flip it to become 1/5. And then to become 1/25th, what would I do? Square it. So it's 5 to the negative 2 power. And that's being raised to what? To 2x. This is 5 to the x minus 5. So I get negative 4x. Yeah, Callie.
Wait, how did you get negative 2?
Okay, so in order to turn this into a fraction, to make 5 go to the denominator, do you understand that's got to be negative, my exponent? So then that makes it become 1/5. And then if I want to get 1/5 into 1/25th, I'm going to square it. Does that make sense? The negative.
Like, how does the negative?
Because our rule for a negative exponent flips the base.
On the base is 5.
Mm-hmm.
Oh, and okay, the negative makes it 1/5, and then the square makes it 1/5.
Yep. Okay, so I have negative 4x equals x minus 5. Negative 5x equals negative 5. So x equals 1. All right. Quietly, with someone next to you, try number 14. Where's your step where you can write this same basis?
Yeah,
Yeah, it'd be
This is going to be from 1 over 2 negative 2. That's what it equals.
Are those the vocab words you just meant? Are those the first two on? You just meant internal and external. Oh, sorry, yeah.
times 2 is 16.
Wait, did you want us to do number 14 also? I mean number 15.
Yeah, I'm doing that one.
Scoresman, did you want us to do number 15 also? No, okay.
All right. Looks like we all pretty much got there. What'd you get? What'd you get? Negative 1/10. You should have rewritten 1/8 as 2 to the negative 3rd power. The negative flips it and makes it become 1/2, and then if you cube 1/2, you get 1/8. Everyone see that if they made a mistake at first? So you had x plus 1 equals negative 9x. So x equals negative 1/10. All right, let's look at number 15. You're going to work it the same way, except that we've got an inequality sign instead of an equals. Okay? All right, so we have 16 to the 2x plus 1 power is less than or equal to 1 over 32. What base should we try and use? 2. Could we use 4? No, because 4, you can't raise 4 to a power to get 32. Yeah. So what could I raise 2 to the power of to get 16? 2 to the 4th. Less than or equal to? Good. 2 to the negative 5th power. Everyone okay with that?
Sure.
Are there questions as to why this is a negative 5? This is a concept that we need to practice, so please let me know if you're not getting it.
So you flip it, which makes it 1 over 2.
Uh-huh.
That's a negative. And then how do you get from 1 over 2 to 1 over 3?
You need to, that's one of those that you got to memorize, that 2 to the 5th is 32. Okay? So this is,
Wait, how high up do we go?
I would go up through like 64 would be fine. 2 to the 6th is 64. And then 3 to the 4th, you should be fine stopping there, 81. So this is 8x plus 4 is less than or equal to 2 to the negative 5th. So 8x plus 4 is less than or equal to negative 5. 8x is less than or equal to negative 9, and x is less than or equal to negative 9. All right, let's think about that for a second. Does it make sense that our x, to plug in up here, has to be less than or equal to a negative value? Which means my x is always going to end up being negative. Why would that need to happen?
So you get
Yeah, because we've got to get that left-hand side less than a fraction of 1/32. So it's got to be a negative that turns it into a fraction, and it's got to be a bigger, a fraction that's got a bigger denominator. Okay? All right, keep your notes out. I'm going to go ahead and pass out your homework. You'll have a nice amount of time